Today we're going to be talking about the next lab, the MQTT lab, MQTT client to be exact. I guess before I get started with that, I posted something in Teams. Hopefully you saw already. You should have. Saying that for the concurrent HTTP server, because I've been out of town, I've given you an extra day to work on it. So now it's due Monday at midnight instead of Friday at midnight or Sunday at midnight, whichever one you think is the right answer. But now it's due Monday at midnight. So I'll be back Monday, so we can ask you can ask questions about that. We can talk about it on Monday. Work on it before then, please. I mean, it's not that hard of a lab, so you should be able to finish it without any of my help. But in case you're stuck, I'd love to help you Monday. Ask questions. So you have until Monday at midnight to work on that. The MQTT lab is historically been pretty easy. You see right here, majority of people finish it within 5 hours. This little break, so use it wisely. We're gonna have a midterm soonish, and then the other labs. The simple TLS client isn't too bad. It's a little more difficult, but then the last lab is probably one of the hardest labs. So, maybe this is a good week for you to get ahead. Finish this lab quickly, and then do the homework, and then start working on the next lab. I don't know. So just a reminder what MQTT is. It's a publisher subscriber protocol. It is an application layer protocol though, but it's publisher and subscriber. So instead of like our clients have been or a server where it's waiting for a request, a publisher subscriber does something different. Now we publish out messages, say, hey, the world, here's a message. Really, you're telling a broker, and the broker figures out how to deliver these to other to people that have subscribed to it. So there's two possible operations. You can publish a message, or you can subscribe to a grouping of messages. A topic is what they call it, and you can sometimes you're just a publisher. So maybe a censor is just a publisher. That's all they care about is just publishing data. And maybe you're just a subscriber, so you just want to read those censor readings. Often though it's intermixed, you might want to do both. For example, a censor might want to be a publisher of censor data, but might want to be a subscriber to a firmware update topic or a topic to change its settings. So rarely are you actually seeing one, a device that's only a publisher, only a subscriber, but it can be done in kind of logically or, simply. That's what you can think of makes sense. So that's what you're going to be building, but you're not going to be doing it from scratch. I think that'd be really cool. I kind of want you guys to do it, but MQTT is kind of a hard protocol. Well, it's not hard, but it's a little more work than I wanted it to be for this type of lab. Maybe I should have you design your own publisher subscriber protocol. It'd be kind of cool. But for now, you're just going to be using a library that implements for you. I think that's why this lab is easy, because really you're just using someone else's code, and it's just how you put that together that matters. But it's still a good exercise, because I want you to get a feel for how a publisher subscriber program works. Specifically, it lends itself to a different type of programming style, kind of more this callback based with these function pointers. And we'll talk about that in a second. So yeah, you're going to be using this library. But before we get to that, I guess MQTT needs a couple pieces of information. Similar to all of our servers and clients, it needs some host name, and it needs a port number. So this is the host name and port number of the broker, not of subscribers or publishers. They're all going to connect to the broker. The broker's main job is to distribute out those messages. It takes care of who's there, who's subscribed to what, who published what. So you're connecting to the broker. The standard ports for MQTT are 1883 and 8883. Similar to HTTP, with it being a port 80, the unencrypted MQTT is on 1883. And then similar to how HTTPS, the encrypted version of HTTP is on port 443, the encrypted version of MQTT is on 883. You don't have to do that, right? Remember, ports, you can do whatever you want, but that's just convention, is to do it in those two places. So you need a host name and a port number. That shouldn't be anything new. But new stuff is you need a client ID. You need to identify yourself. Who are you when you talk to the broker? Your IP address isn't sufficient. Well, first of all, it's a application layer protocol, so really, IP addresses shouldn't be known by the application layer protocol, but it can figure that out. But your IP address can change throughout a connection potentially. So you need some kind of unique identifier to identify yourself to the broker between connections or between IP addresses. So an IP address isn't enough. The next thing you need is a topic. So typically they're structured with slashes between them, similar to like URLs. And usually you start with more general and you get more and more specific. So, if you want to communicate with a light of some kind, it might be like your home, and then like, oh, it's upstairs, and then it's in the bedroom of my home, and then it's that light, the thing you're actually talking to. So you need this both to publish, right? You can say, hey, I have this message, let me publish it out, but what topic do you want to publish it on? And then you also need it when you're going to subscribe, because you need to tell the broker what topics are you interested in. Okay. Next piece of information you need is a message of some kind. But this is only for if you're a publisher. You need to obviously publish out a message. If you're a subscriber, you don't have a message. You just have a topic, and then you get messages when they get published out. Lastly, I just have here just because I want you to learn a little bit more about MQTT, but you need a host name and password. You don't really need it for this lab as I put here. They're actually not going to be using those, but sometimes you want to have security, right, built into this. You want to have some authentication because if let's say you do have a light upstairs in your house, in your bedroom, you don't want anyone just being able to publish a message to turn it on or off or something like that, right? You only want authorized people. So you need some kind of concept of a username and password to ensure that people that are allowed to control things can and people that aren't won't. We won't be using this in this lab. We'll just keep it open. But if you want to actually use this in real life, you would really want to use a username and password. Even if you think this stuff isn't particularly secure, it's always a good idea. Okay, so what's this protocol we're going to use? I mean, we're using a publisher-subscriber protocol, but like, what's the topic structure going to be like? What are the messages that we're sending out? Like, what's that look like? So we're going to go back to our protocol we've been using for all the other labs, lab 1, 2, 3, I guess 4 as well, with this idea of transforming text. I know you're probably getting tired of it. I apologize. This is the last one you'll have to do this with. But why I wanted to do this specific protocol is because you're familiar with it. So I thought it'd be kind of fun to bring back an old thing, but in a new way, and see how it feels, what works well, what doesn't work. So how it's going to work is you're going to publish a message with this structure, with a topic structure like this, where it's going to be your net ID / what action you want to perform, uppercase, lowercase, shuffle, random, all those ones, and then / request, the actual word request. So these brackets mean fill it in. So you're going to fill in your net ID here. You're going to erase the brackets, the angle brackets, and then what action you're going to put in there as well. / request. Okay, and then the payload of the message, so when you publish out this message, you have a topic, but you also have a message, as I said up here. The payload of it is going to be the text you want to transform. So use it as an example. Here is someone's net ID. Then what action you want to perform, uppercase, and then you're going to say, hey, request. So essentially what we're saying is this person is requesting that you uppercase this text. That's what you're going to say. And maybe like the message is networking is the best. The broker doesn't know what this is, right? The broker is just brokering messages, so it doesn't know how to uppercase things. So I've actually written a subscriber, a client, that's going to look for your requests. It's going to look for this structure. And when it sees this structure, it's going to take in that message. It's going to transform it how you asked it to transform it. And then it's going to publish out another message with your net ID, with the action, but then / response. So it's your job to subscribe to that topic. So when you publish out and then you're subscribed, you'll get that message back, but it'll be transformed. So to continue on with the example, you get your net ID / uppercase / response, not request, but response, because someone's responding back to you with the payload of networking is the best. So that's the protocol. Now, I do have a disclaimer here that this protocol is originally designed for a publisher-subscriber model, right? And that's what I'm sorry, I said that backwards. This protocol has been designed for a client-server structure, right? That's what we've been doing for the last 4 labs. and then some. Uh, this isn't the best fit for a publisher subscriber model. It's not very intuitive. Kind of, it's a little like weird of having to have this structure and this request and response. Uh, there are better examples that would lend themselves better to this kind of structure. Specifically, something like a chat app, which I used to have students do. It lends itself better. You'd say, "Hey, I subscribe to any message anyone that's sending me a message, I want to subscribe to it." And then when you publish, you say, "Hey, this person, I want to send a message to you." And so that's a little bit more intuitive. Uh, this one's not as much, but I wanted, like I said, to bring in something old that you're familiar with to see how it works in this new context. If you have feedback, I'd love to hear it. If you feel like maybe I could come up with a better way of doing this, then I'd be all ears. In previous years, they had two MQTT labs, one where they did this and then one where they actually built a chat server. But I felt like it was a little too much of MQTT, and I switched it out for the Nibble torrent. Okay, the CLI. Let's talk about that a little bit. It's nothing particularly crazy. All the optional arguments have stayed the same, but now we have 3 required positional arguments. So similar to here, we need some more information, right? So you'll need to provide your net ID. That'll be the first positional argument. Then you need your action, second positional argument. And once again, you have to constrain it to just that list of possible actions. If I type in foobar, you better return an error, right? Say that's not allowed. That's not a valid action. And then a message. The message that you want to convert or perform action on. Okay. So that's the CLI. Really, this is the only new part here, but it shouldn't be too bad in Python. Let's talk about the requirements. So use same version of Python you've been using for the rest of the labs. You are allowed one third-party library, a specific one. I'm not saying you get to choose which one. You're allowed to use the Paho MQTT client library. I'll show you what that looks like in a second, but this is a really good library that implements MQTT in Python. All other libraries are off limits, so don't use anything else. Don't pip install anything, but you are allowed to pip install that. Okay, so this is the first time you're allowed to ever pip install anything. This is what you need to name your program. Use the uses message. The default port. This is different than what we've been doing. We've been incrementing that was 80, 80, 0, and then 1, 2, 3, 4. Now we're going with 1883. I don't know why I did that. I think it's just because, I did it because it's the standard MQTT port, but I don't know, maybe I should keep going with convention. But yep, so use the standard port and localhost should be your default host name. I need to kind of continue the normal standards of printing everything to standard out or standard error. Your client, okay, needs to be able to publish and subscribe using QoS1. I don't think we ever talked about that when we talked about MQTT. MQTT has different quality of services. That's what QoS stands for, quality of service. Let me see if I can find a diagram. MQTT, QoS. There's some nice diagrams out there. Oh, dang it. My internet is not very good here in Croatia, so that might work. Might take a while. Okay. Yeah, maybe not then. Let me just try refreshing one more time. Okay. Well, sorry about that. So QoS is quality of service. It's how many times, let's see how to put this. Like, how many times do you want to send the message? So when I publish out a message, there is a chance it could fail, right? That's actually an interesting point. That's something worth talking about because it's using TCP MQTT. So you would say it should have no chance of failing because MQTT is a reliable protocol. And you're right-ish, but TCP is actually not as reliable as you think. It's reliable for a given connection. If the connection's there, then it will be reliable. But if the connection ever gets lost, like here in Croatia, my connections are getting lost a lot, then TCP is no longer reliable. In fact, it's very unreliable in a way, ironically. Because what could happen here? I'll throw this example at you, and this has really happened to me many times when I'm doing networking research and stuff. Not in my normal life, but uh, you are sending data and a connection it times out. Something in your TCP connection just goes bad. Maybe you have really bad internet, that lots of packet loss, and just gives up. And TCP says, I can't do anything. But all the data you've already called send on, or that's in the buffer of the operating system that you've said sent, and it took it from you. So you said you can move on and call send again or move on. That all gets lost because your operating system says, "Oh, okay, this TCP socket is done. Connection's lost. Let's just give up." And it closes the connection and deletes all the buffers, and all that data you just thought was sent but actually wasn't sent uh, was is lost because you don't see when acknowledgments happen. The operating system takes care of that for you. So that's kind of a nice thing, but it's also a bad thing if it fails. So TCP is not reliable over multiple connections. It's reliable for a given connection if that connection is working properly. So what MQTT is providing is reliability across multiple connections. It will do the job of when you disconnect from one connection because something happens, it will reconnect, or maybe even you switch to a different IP address. You are mobile node and you're moving around. MQTT will take care of that all for you behind the scenes. It will set up the TCP connection, and when you get disconnected, it'll reset it up again. So as a result, it takes care of buffering that data for you. So when we say it provides quality of service and reliability, it's over multiple connections. So there's 3 levels of quality of service. Quality of service 0, that's the lowest. That is called fire and forget. It just sends out the message. It doesn't care if it got to the broker. I mean, it cares as much as TCP cares, but beyond TCP. So if you're not connected to the broker right now, it'll just say, okay, that won't send it, or if for some reason that connection got disrupted in the middle of it sending it, it won't care. Fire and forget. It's in its name. Uh, that's good for something. Maybe it's not a critical data message, then you want to send it. Is this loaded yet? No. Okay. Okay. Then there's QoS1. That I forget. It's send at least once. Hopefully, I have these names right. That's an interesting case. Why is it at least once? So here, what can happen with quality service 1? It'll ensure that the packet at least got there at least once. It means it could actually get there more than once, which is weird, but that could happen, right? What if I send a connection or set up a connection, send it, it got to the server properly, but then my TCP connection got just messed up. So the server has it, the broker got it, it publishes it out, and then but MQTT doesn't know that it got there. Then I set up a new connection, I'll publish it again, it'll assure. So this has acknowledgments built into it. So I publish a message, and then the broker will send me acknowledgement, not a TCP acknowledgement, an MQTT acknowledgement that's on top of a TCP acknowledgement. Say, yes, I received this and I published it out. So there are some weird corner cases where you could actually publish more than once with QoS1. But you'll do it at least once. It'll guarantee that. So it'll keep trying until it's received that acknowledgement from the broker. Is this loaded yet? No, I'm still, okay, I'm giving up. Okay, and then there's quality service 2. And that is the most stringent quality of service, and that's publish only once. I think that's the name of it. Maybe there's a fancier name, but it's where it will only publish that message once for sure, and that's the heaviest form of quality service because what it has to do is send the request, get acknowledgement, and then the client has to acknowledge that acknowledgement, and then the server has to acknowledge that acknowledgement. So it's actually four back and forth. So 4-way handshake, you could call it, where it's everyone's making sure that they're in the right state so that it was only sent once. That's quality service 2. Sometimes you want that. So it really depends on what you need. Maybe fire and forget's okay because it's not an important message. Maybe sending it once. I usually choose quality service 1. I'm usually using censored data, publishing censored data, and I don't care if it's published more than once by accident because I'll take care of dealing that within my database. I often have a timestamp involved, and so I can just look, say, oh, there's a sensor reading from the exact same time. That must mean it's duplicate data, and then you just get rid of it. And so you don't worry about MQTT dealing with that. You deal with it upstream, or downstream, I guess, at the database level or something like that. But maybe if it's like, hey, launch this nuclear code publication, then you probably only want that to get sent once. So you'd want to just choose quality service 2. Okay, sorry, that was a long explanation, but I got a captive audience, so that's why I gave it. And it's also good to know. So for this, you'll do quality of service 1, so it'll send it at least once. Okay. Because this lab is relatively light, there's questions that I need you to answer as well. And yeah, you'll have to submit those. So yes, answer these questions and add that to your repository. Okay, so that's the requirements. I haven't really spoken about how you're going to do this. Let's talk about that next. Or first, let's talk about testing, then I'll show you the code. I have a broker set up here. That's the URL, or that's the host name, the support number. So you can point your client at this, and that should work fine. But if you don't want to use mine, or you're going to have to use it eventually, because I have the client on the other end that's listening. So you're going to have to test with that performs the action of the client. But if you're like just figuring out how to publish and subscribe and stuff like that, you can also install Mosquito on your computer. That's the popular open source broker software. And then you can also install Mosquito Pub and Sub. Mosquito Pub and Sub should be installed on the Digital Lab computers. I've asked them to do that, and so hopefully they've done it by the time you're watching this video. Those are nice clients that will let you subscribe to messages and publish messages, and so that can be a way to test and interact with your client. Of course, you're going to need to have the Mosquito server. I should have had them install that as well. Okay. So let's go through this library, because that will kind of indicate how you do this, how you go about doing this. So here's the library that I've linked to. It's called Paho. It's part of Eclipse Foundation. The documentation is pretty good. It might not make very much sense when you first start out. Sometimes things are like that. So it's worth, to me, looking at the code and understanding that, because sometimes you need to have context around the code. First, like code, and then it'll help you have context for what's going on. But so what I would do is actually go to some examples, specifically the publish example and the subscribe example. So this shows you how to publish a message. So if you can just publish a single message, here's the topic, the payload, and then the host name. You want to also add a port number. That should be something you can do in here. So you want to, maybe there's a better example. Yeah, there's a better example right here. So let me back up. This is a library that lets you interact with MQTT and publish. So let me find an example right here. Okay. So here's kind of a classic example. You're going to create an MQTT client, specify what version. I haven't told you what version. I'm pretty sure it's version 2. I should verify that. I'm pretty sure it's not the latest version. I haven't updated my broker for a while. And then what we're going to do is provide some callbacks. So this maybe is a little interesting syntax. You should feel somewhat comfortable with this in that you've done callbacks already in C, and that's way harder than this. But what we're doing here in Python is we're saying, hey, like on connect, that's a function. That's up here. But cool thing about Python is you can create functions or use functions as if they're variables or as if they're values. So what I'm saying is use this function called onConnect in your library called onConnect. So what we're doing is we're specifying that what function should MQTT call when you connect to the server? What function should it call when it gets a message? It's called onMessage onConnect. So these are set to none, for example, by default. So it won't do any behavior. You're overriding that behavior. Say, hey, on connect, call my onConnect. This can be named whatever you want, but they often just use the same name because it's convenient. But you essentially say, hey, on connect, call this function, or on a message, call this function. So here they are right here. Then you're going to go ahead and try connect. But this could take a long time. You don't know how long it could take, right? It's networking. So that's why you have the on connect function, because you'll know when it gets connected. So in fact, how MQTT set up is .connect will not actually block. Uh, when you were creating sockets in TCP, that blocked. That would wait until that line finished, until actually it had happened, and then move on to the next one. In this case, this one does not block. It just says, hey, go to try connect, but you know, I'll let you know that I've connected by calling this function on your behalf. So you call connect, you ask it to connect, but then you have to do this looping. This looping is a little confusing, and you don't have to call loop forever. There's actually different functions that you should be aware of. But what the loop does is it checks when we call loop, that means like check for messages MQTT, handle connection requests, publish out messages. That's called like an event loop, is what that's called in programming. And so you're going to have the MQTT, how it's implemented is through a loop. And that's what's calling these functions for you, is the event loop. So when it got a message internally here in this function, it will then call out to this function right here. Or when it gets connection, it'll call it here. So that's what this loop forever. Now this loop forever does what it says. It loops forever. You might not want that behavior in this lab, because this one does block forever, because it'll loop forever. This is a fine function to call if this is all you want to do, maybe just like print out messages or subscribe to things. But you're going to be wanting to do a little bit more than that. So this is probably not the best function. You can make it work, or you might want to use it actually. It really kind of depends on how you want to design your program. Okay, but one thing I want to point out here that I think is really critical is notice how in the on connect, it subscribes to a message, or to a topic, I should say. Why does it do it on the on connect? It's kind of interesting. So we could move this client.subscribe down here under this line. But remember, like no functions in this library block. So what happens if you call connect and then you call subscribe? What if that connection doesn't happen for a long time? This library is not smart enough to hold on to that subscription between disconnections or reconnections. And so you would lose that subscription potentially, or if timing didn't work out. So when you call subscribe in your on connect, you're guaranteed every time you connect, that's the next thing you do is say, hey, make sure to subscribe to this message, this topic. Sorry, I keep on saying message, this topic. So this is kind of like a event-oriented programming, where it's like, okay, on this event, do this other event. And there's actually an on subscribe callback as well. You don't really care about that as much, but you could override that. Say, what do I do when I've successfully subscribed? Because subscribing isn't something that just happens on the client. It also happens on the broker. I have to tell the broker, hey, I'm subscribed to this message. So it's not something we can just do whenever we want. We have to send out another request to the broker. And so that is a network call. And so there is a corresponding on subscribe callback that you could implement, but you don't need to. Okay, so that's one example. So this is what you're going to be doing. You're going to be taking this code, adding some glue between. So what I would suggest you do is you look at these two examples. I've posted them right here. So I would spend a lot of time looking at these. This one, it shows you how to do a publication and wait for that publication to actually happen. And then this one shows you how to subscribe to something. It's pretty much what I just showed you. Because that's what you're going to be doing in this lab. Just to go back up here and remind you what you're going to be doing. You're going to be publishing out a request with the payload, and then you're going to be subscribing to a response. So you're going to be a publisher and a subscriber. So you're going to take this code. I would honestly just run this as is, paste into your Python code, and then run it and see if it works. Maybe you have to change some things. You'll probably want to change to my server or your test server and make sure that works properly. And then you're going to want to maybe publish out different messages, not tuple bar and class bar. So kind of morph it into what it needs to be to publish. And then you're then going to maybe want to set up a subscriber as well. And you're going to want to subscribe. So then I would put that publication code aside and then copy this subscribe code inside your file and start messing around with it. Make it do what you want it to do. Maybe you have to do some Mosquito publications as well. Mosquito, yeah, pub, using those clients to help you out with that. And then once you have those two files working the way you want them to work that are closely related, then I would start gluing this together. Because like, look, you have a client on this one, you have a client on this one, so you only need one client. So that's example. You could kind of override, keep those, merge those together. You have an on message, on connect, and on publish. You have an on message, on connect, on subscribe. So very close. There's a couple of things, related. And then the subscribe and publish are different. So that's what we're going to be doing, is gluing these two files together. And that's kind of it. Send out your publication, publish it out, and then wait for a response back for the subscription. So the devil in this lab is in the details, though. And it's not hard, but there'll be some stumbling blocks. The first one I can think of, I hesitate to almost tell you because I'm almost going to make it a little too easy, is that you want to be careful about the order in which you publish and subscribe. I've been really saying it that you're going to publish first and then subscribe. But the problem with that is, let's say I publish out my message and then I subscribe. Remember, subscription takes time. It's not going to be instantaneous. So if I've sent that publication to the broker and it receives that message, it's going to say, oh, no, subscribe to this. And then, or no, it'll publish it to my client. My client will then respond with the transformed message, send it to the broker, and the broker will say, oh, no one subscribed to this. I'm going to drop it. And then maybe you send your subscription. So you got to be careful. What if you publish it out and then your subscription's too slow that you don't see the response? So it'd be better if you subscribe first and then publish your message, because you got that subscription, it's ready to go. This broker knows you're interested in this topic, and then you send out your publication. My client will transform the text, publish out its message, and then you'll receive the response. So make sure you follow that order instead. Another thing you're going to have to be worried about is publications aren't instantaneous. You're going to have to wait for that to finish. Oh, well, that's fun. People sometimes, a program closes out before it's had a chance to receive the subscription. I'll just put it that way. So you publish it out and you say, okay, great. And then you exit out because Python's really fast relative to the network. So it'll publish it and once it's successfully published, it'll move on and look and say, okay, I'm done, and stop. So you're going to have to be careful about, you need to not just exit the program right away. You need to wait for that subscription to be filled. And it should be filled at least once, right? Only once, in fact, actually. So you're going to want to have some flag or some kind of state to say, okay, this subscription better happen. And if it doesn't happen, I'm going to sit here and wait until it does happen. Otherwise, your program will exit and then you'll be like, what's going on? And it's because my client tried to publish it, but you exit out before I could actually do it. So those are the two stumbling blocks. Other than that, just copy this code. You ran out of time. You can't see it now. And put it together. Yeah, so that's it for this lab. Good luck. I'm trying to think if there's anything else. Let me know if you have questions in Teams. I'll be on there looking. So yeah, if you have questions on this, I know you're probably just working on your concurrent HP server right now, but definitely be aware of this lab. I'd say get it done quick. It could probably just take you a day, a couple hours in a day. So get that done. Have a good Friday, if you're watching this on Friday, and I will see you all on Monday. Okay, bye.